Welcome to the video. My name is Pushpinder Gill. So today we are going to do variation. This is going to be my email address where you can send me your valuable feedback. So what is variation actually? Variation is how things vary according to each other. Now this topic is it's taken out. It's the root of all other topics like simple interest, compound interest, percentages, profit and loss, time and work. This is the base for all of them, because in everywhere, even in the normal world, we say how things vary. If you work hard, you'll get more marks. So there's a direct variation over there. So we're going to learn the variation thing. Fine. So let's move forward and start with the learning. Now, usually if A is directly varying with B, then we can represent it as like this. We usually represent it like this, or we can say that A is equal to K times B, where K is the constant. Let's suppose if I say, let's suppose your speed is constant, right? So if the speed is constant, so the more distance you travel, the more time are you going to take, which is nothing but distance is equal to speed into time, and speed is the constant over here. So anywhere in all over the world, if you see A is directly proportional to B, that means A is equal to K times B, and this value of K never changes, right? That means this K is constant, and there is a particular value that will always be here, right? So whenever things are directly proportional to each other, you can easily say A is equal to KB, or I can say, if I bring this B down here, I can say A upon B is constant. Fine. Okay. Now if A is inversely proportional to B, it inversely varies with B, then we can say A is directly proportional to 1 by B, right? So if A is directly proportional to 1 by B, that means A is equal to K times 1 by B, or I can say the product of both of them is going to be constant. Let's say, for example, if distance is supposed to be constant, let's suppose you want to travel 10 kilometers. If you double your speed, right, you're going to take half the time. If you triple your speed, you're going to take 1/3 of the time. So which is nothing but distance is equal to speed into time. That means these two things are inversely proportional to each other, and the product of these two things is a constant. That is the distance, right? So we have established two things. If A is directly proportional to B, their division is constant, and if A is inversely proportional to B, their product is a constant. Fine. So this is something that we have established. Now let's try using this in the question. Now let's see this. If A varies directly with B, then we can say A is equal to K times B. If A varies directly with the square of B, then we can say A is equal to K times B square. Similarly for the square root, similarly for the inverse functions as well. Fine. And for when it varies indirectly, that means their product is constant, and when it varies directly, that means their division is constant. So you can take this either way. Fine. So let's go ahead and solve some questions. So x varies inversely with the square root of y. What can you get from that? That means x into square root of y is equal to a constant. Why there is a product here? Because it varies inversely. Whenever it varies inversely, their product is constant, right? Okay, so x varies inversely with the square root of y. Now when y is 9, x is 12. So the value of x is 12 when the value of y is 9. So this is going to give me the value for k, which is going to be 12 times 3, that is 36. Now he's asking me what is the value of x when y is equal to 16. So if you just substitute the value here, x you have to calculate, y is under root of 16, that is equal to the value of k, that is the constant. Fine. So that means x is nothing but 36 by 4, that is 9. Fine. So I hope you understood how we solved this question. X varies inversely with the square root of y. That means their product is constant, and from there you find the constant and substitute it to the next variable. Now let's see this question. A varies directly with the cube of B and inversely with C. Now if A is equal to 6, B equal to 2 and C equal to 4, find A when the values of B and C are given. Now let's do this question step by step. A varies directly with the cube of B. That means if it varies directly, that means A upon B cube is a constant, right? It's some constant. And inversely with C, that means even if I multiply with C, is gonna give me some value of constant. Let us say the constant is K1. So that means A is inversely proportional to B cube, that means A by B cube, into C, it's inverse, sorry, A is directly proportional to B cube, that means A by B cube, inversely proportional to C, that means A into C. This is why it's going to give me a constant. Fine. Now let's go ahead and solve the question. Now we know the value of A is 6. We know the value of B is 2. Let's put 8 here. 2 cube is 8 into the value of C, that is 4. That is going to give me the value of K1, which is going to be nothing but a 3. So I know that the value of K1 is 3. Now let's use this formula and try to find the value of A when B equal to 4 and C equal to 6. So A upon B cube, B is 4, 4 cube is 64 times C, C is 6, C is 6 is equal to 3, right? So this 3 cancels this 2. Now why did I put 3 here? Because that's the value of K1. So this is gonna give it as 32. That means A is nothing but 32. So you see how easily we solve this question once we know that how things vary. Now A varies directly with the cube of B, that means A by B cube, and inversely with C, that means multiplied by C. Whenever things are inversely proportional, their product is constant, and when the things are directly proportional, their division is constant. Right? Okay. Now let's see this question. Now this is a very typical question in terms of A and B, and you can get this question in terms of time, speed, distance as well, and all that different forms as well. Now A varies directly with B. If B increases by 25%, then what will happen to A? Now you see A varies directly with B, right? That means A upon B is a constant. Now if A upon B is a constant, now B is increasing by 25%. Now if you watched my percentage videos, you know if anything increases by 25%, it gets multiplied by 1.25. Right? Or if anything increases by 25%, it gets multiplied by 1 plus 1 by 4, or you can say 5 by 4, which is nothing but 1.25. So it's very important that you watch the percentage video first if you don't understand. So if B increases by 25%, it gets multiplied by 1.25. To keep this constant, A also has to get multiplied with 1.25. Now A is also getting multiplied with 1.25. That means A is also increasing by 25%. Now you might say, okay, it's easy. Both are directly proportional. B increases by 25%. A has to increase by 25%. But this is not always true in terms of proportionality, because let's see, you'll come to know that in the coming questions. A varies indirectly with B. A increases by 20%. Then what will happen to B? Now you know that A varies indirectly with B. That means A times B is a constant. Now A has increased by 20%. Now getting increased by 20% means 20% is 1 by 5, means getting multiplied by 1 plus 1 by 5 or 6 by 5. Or you can say that getting multiplied by simply 1.2, which is nothing again but 6.5. Now A increased by 20%. That means this got multiplied by 6 by 5. Right? So this became this. Now to keep the K constant, B has to get to multiplied by 5 by 6, so that everything cancels out each other and you still get the same value for K. Now A got multiplied by 6 by 5. That means B got multiplied by 5 by 6. So when a number gets multiplied by 5 by 6, from B it became 5 by 6B. That means it reduced by 1 by 6. 1 by 6 is nothing but 16.66%. If you watch the percentage video, this will be very easy for you, right? So A into B, the product is constant. A is getting multiplied by 6 by 5. B is supposed to get multiplied by 5 by 6. That means if Earlier it was b, now it is 5 by 6b. That means it must have reduced by 1 by 6. 1 by 6 means 16.66% decrease. Fine. So you can get this question easily. You can say, okay, alright, I increase my speed by 20%. What percent of time I'm saving? This is nothing but the same thing. You see, a into b is k. Distance is equal to speed into time. What if I keep distance constant? Then the same thing is going to happen with speed and time. Speed getting multiplied by 6 by 5, time will get multiplied by 5 by 6. Same, if you increase your speed by 20%, you're going to save 16.66% of the times, right? So yes, now you can't easily say if a increases by 20%, b has to decrease by 20%. That's wrong. So this is the way you should be doing these kind of questions. Fine. So let's move forward. Now P varies directly with Q and inversely with R, right? Now let's make that equation. Now P varies directly with Q. That means P upon Q is a constant, and inversely with R, that means R comes and the product that is equal to a constant, right? So I hope everyone understood this. Very easy. If Q increases by 20% and R decreases by 20%, fine. So P, what is happening? Q is increasing by 20%. That means Q is getting multiplied here by 1.2. Fine. So Q is getting multiplied by 1.2. It is increasing by 20%. R is decreasing by 20%. If something decreases by 20%, then only 80% remains. That means R is getting multiplied by 0.8. However, this k is constant. Let us say this is nothing but 6 by 5. This is nothing but 8 by 10. So P upon Q into R. So this is 8 by 10, and this is nothing but 6 by 5, right? So since 6 by 5 is the bottom, so it will come like this. So 5 times 2, 2 times 4, and 2 times 2, and 2 times 3. So that means overall the equation got multiplied by 2 by 3. However, the figure corresponding, the figure on the opposite side is a constant. So to keep it constant, I have to multiply P by 3 by 2 so that it cancels and I am left with the constant again. So P is getting multiplied by 3 by 2. 3 by 2 is nothing but 1.5. When a number gets multiplied by 1.5, it increases by 50%. Fine, this is pretty simple stuff. When a number gets multiplied by 1.5, it increases by 50%, which is nothing but 1 plus 50 by 100, right? So this is nothing but 50%. So you see how easy the question was. P varies directly with Q. That means P upon Q is a constant. And inversely with R. That means P into R is the constant. And if Q increases by 20%, Q gets multiplied by 1.2. R decreases by 20%. R gets multiplied by 0.8. So overall it got multiplied by 2 by 3. That means P has to get multiplied by 3 by 2 to keep the product constant. That means it has increased by 50%. Fine. So let's go ahead and move forward and see a different question. Now the cost of an apple is directly proportional to the square of its weight. So that means the cost of an apple is directly proportional. So that means division is constant to the square of the weight. Let me weight square is a constant. Alright. Now what is he saying? He's saying if the cost of an apple which weighs 200 gram is $24. So that means 24 divided by 200 square, which is nothing but 4 times 0. That is equal to the constant. Fine. What is the cost of an apple which weighs 250 gram? Now this is the value of constant over here. 24 upon 400 like this is equal to, now the weight is 250. So that means cost upon 250 times 250. Fine. So if you see, these zeros would go away like this. This 25 is gonna cut this 100 by 4. 4 times 6, and 2 times 2, 2 times 3. So this is nothing but 75 by 2, which is 37.5. Easy, right? So you just have to come up with this, and then everything turns up itself for you. So the cost of an apple was directly proportional to the square of its weight. When it's directly proportional, that means the division is constant, and then the values were given, you just had to substitute the values. Fine. Okay, the rate of flow of water in pipes varies inversely as the square of the radius of the pipe. Now, the rate of flow of water in the pipe varies inversely to the square of the radius. Now, if it varies inversely, let me call the flow as F. Flow into, it is inversely varying, that means the product is constant, into the square of the radius is a constant. Now the product of these two is constant. What is the ratio of the rate of flow in two pipes of diameter 2 centimeter and diameter 4 centimeter? Now there are two pipes, the one with diameter 2 centimeter, the one with diameter 4 centimeter. So now always the product is going to remain constant, it's going to remain K always. So that means the flow over here is K upon, now if the diameter is 2, the radius is 1 square, that is 1. Over here the flow is, let me call it flow 1, flow 2. Over here the flow is K upon, if diameter is 4, the radius is 2 square, that is 4. Now he is asking you the ratio of their rates of flows. So the ratio of this by this, that means F1 by F2 is nothing but, now you have to calculate with diameter 2 and with diameter 4, right? So that means that is going to be 4 by 1. So that is the answer. Fine. So I hope everyone understood. This was an easy question, just had to come up with this equation and then everything was solvable, right? So that is what these the one who puts these questions, he wants you to do, right? He doesn't want you to substitute values and try that stuff. Just do this and you'll be able to get the answer. Okay, reduction of speed of a railway engine varies directly with square root of the number of bogies attached to it. The speed of the engine is 75 kilometers per hour when there is no bogie attached to it, and 60 kilometers per hour when there are 25 bogies attached to it, right? Now let's see this question. Now this question says the reduction of speed of a railway engine varies directly with the square root of the number of bogies attached to it. Now it's varying directly, that means the reduction in speed divided by the number of bogies under root is a constant. Fine. The reduction in speed varies directly with the square root of the number of bogies. That means this is our equation over here. Now let's see what have we got. Now he's saying the speed of the engine is 75 kilometers per hour when there is no bogie attached to it, all right, and 60 kilometers per hour when there are 25 bogies attached to it. So when there is no bogie attached, so the reduction of the speed of the engine is this. That means this is the actual speed of the engine with no bogies attached. Let us find the value of K using this equation. Now the speed is 60 when there are 25 bogies attached. So by how much amount did the speed reduce? It was 75 earlier, now it is 60. That means the speed reduced by 15 divided by under root of 25. That is the value of K, which is nothing but 15 by 5, that is 3. So this is the value of K. So I hope everyone understood. This is not the speed, this is the reduction in the speed. Now what is the speed of the engine when 64 bogies are attached to it? So speed of the engine when 64 bogies are attached to it is, now we calculate the reduction of the speed. Reduction of the speed by under root of 64 is equal to 3. That means the reduction of speed is equal to 8 times 3, that is 24. That means the speed is going to reduce by 24. The normal speed is 75 minus 24 is going to give you the answer, right? So I hope everyone understood how did I solve this question. This question, believe me, if you don't know this method, you won't be able to solve it pretty easily. So it will take a lot of effort for you to solve it without knowing the actual math behind it. So what was it? The reduction of the speed varies directly with the square root of the number of bogies attached to it. So this is the reduction of speed divided by the square root of number of bogies is a constant, right? So if the speed is there is no bogie attached, the speed is 75. If there is a bogie, there are 25 bogies attached, the speed is 60. That means a reduction of 15 bogies gives us the value of K. K is 3. You just plug in, substitute those values into this and you get your answer. Fine. Okay. Okay, the reduction of speed of a railway engine varies directly. Now, this is the same question, but in this he's asking what is the maximum number of bogies that can be attached so that the engine can still move. So let's try to do one thing. Let's bring the engine to the halt. From 75, let us reduce the speed down to 0. Right? So that means my reduction in speed would be 75. And I have to calculate the number of bogies, right? I know the value of k is equal to 3 from the previous question. So if you see in the previous question, we came up with this formula that reduction of speed divided by square root of the number of bogies is equal to 3. So if you just substitute there, 75 divided by under root of n gives us 3. That means under root of n gives us 25, or n gives us 625. That means if I attach 625 bogies, my train is gonna come down to a speed of 0. But I want the train to be still moving. That means the maximum number of bogies that I can attach is 624. Fine. So yes, it looks an easy question when I solve it, because we have that technique, but you need to have that technique. If you don't have it, you won't be able to solve this question pretty easily. Fine. So let's go ahead and move forward. So this was about the video on the first video on variation, where we did direct variation and indirect variation. So there's going to be more videos. We'll be doing stuff like linear variation when there are fixed costs and variable costs involved. So that we'll be doing in the coming videos as well. Fine. And there'll be some more practice videos, and if there is any new concept, we'll do that as well. Fine. So this is my email address. Don't forget to send me your valuable feedback. My name here. Don't forget to like us on the Facebook. Right, we're right there on the Facebook, so you can like there. Fine. So this was about it. Thank you very much.